So in this problem here, we have a 800 seat arena sold out every night at $3 a seat. So they figured that they can make more money if they sell the seats at a higher price. However, as they increase the price, the attendance is going to drop, okay, because it's more expensive, the less people that are going to want to come. So here it says for every $3, the survey indicates that every dollar increase in price, the attendance drops by 100 people. So what ticket price results in the greatest revenue? Okay, so first thing is we want to make sure we know the quantity that we're maximizing. Here it's revenue. So we need an equation for revenue. So revenue is the total money brought in, and that's going to be the price of the ticket times the number of seats sold. So that's the total amount of money that you're going to bring into your business. Okay, so this is our equation that we're going to maximize. So we need a variable for this. So what is it that we're going to change to get a relationship as we increase price and decrease the seats sold? How would we get a relationship for revenue? Okay, well, we're going to set it up this way. So our revenue is going to be equal to the price. Well, it's $3 a seat. Okay, and the number of seats is 800. Okay, that's our starting point. Now we need to change this. So what we're going to do is do this. Revenue is equal to, well, if we start with $3, we're going to increase the price by X. Okay, so for every dollar we increase, what's going to happen to the number of seats? Well, we're going to take away 100 groups of X. Okay, so for every $1 we have increase, we have 100 person decrease. And by doing this, now we've generated our quadratic relationship. So once we have our relationship, we just need to find the max. So we can do this again in a few different ways. Here we have zeros, 0 at 3, negative 3, 0 at positive 8, and we can actually work out our 0 using our average formula. So negative 3 plus positive 8 divided by 2, that's going to give us, looks like 2.5 for X. So that means that for every $1 times 2.4, X is 2.5. So if we have a $2.50 increase, we're going to decrease by 250 people, and that will give us the vertex or the maximum here. Okay, so we can say that X is equal to 2.5, or what is the greatest revenue? So we have to calculate the revenue. So the ticket price. So this represents the ticket price. So the ticket price is 3 plus 1 times 2.5, which is equal to $5.50. Okay, this represents the number of tickets sold. So that works out to be 800 minus 100 times 2.5. And that's going to give us 550 tickets sold. Okay, so we can solve it that way by finding the zeros there. I can do it an alternative way by, again, completing the square. So R is equal to, when I multiply this all out, I get negative 100 x squared plus 800 minus 300, so plus 500 x, and then plus 2,400. Okay, so I can complete the square. Okay, so completing the square, I'm going to take half of 5 and square it, which is 6.25. Okay, and I did balance that with positive 6.25, so 625. So that's negative 100 groups. So I'm going to add 625. I'm going to end up with negative 100 x minus 2.5 squared plus $3,025. Okay, so our maximum revenue is $3,025. And again, we could also work that out once we had solved for the ticket price and the tickets sold. If we multiply those together, again, we're going to end up with $3,025 for maximum revenue. Okay, so bike sell, so these types of relationship, these revenue type relationships, these tend to be quadratic, and we can maximize and find the max min of these using the quadratics.